Hey guys, welcome to Inspire Chemistry, and today we are doing the second part of the acidic radicals. The first part, if you've not seen the first part video, please do watch that video and we'll give you the link in the description box. And if you remember, I told you if you don't find a volatile product in your volatile product after addition of acids, there are two possibilities. One is the precipitate type and the second one is the redox type. So I told you that in redox precipitate type there can be fluoride minus, sulfate minus, BO3 minus, phosphate minus. So these are all precipitate type of reactions. So if you add sand and concentrated H2SO4 to the radical, if it actually was a fluoride radical, it will give you a waxy white deposition. So please pay attention to the precipitates and their colors. Okay, so it's a waxy white, it gives a waxy white deposition. This gives a pre-conformation test for fluoride ion. Now if you had a sulfate ion in your mixture, then if you add BaCl2 to it, you'll yield a white PPT of BaSO4. This is one of the most common radicals asked in 11th and 12th examination, and this might be asked in your exams as well. So barium sulfate is a white precipitate. Now if you look at borate, if you for the test of borate, what you do is you take the compound in your test tube and you add a concentrated H2SO4 to it, then add some ethanol or methanol, whatever you have in your compound, and this will, if you take it to the flame, it will give you a green edged flame. If you take a burning matchstick towards the mouth of the your test tube, this will give you a green edged flame. This is because the compound of boron compound of triethoxy boron, or if you use a methanol in this detection, you will get a boron OCH3 whole thrice. The green color is responsible, the species is this too. So, and if you had a phosphate ion in your mixture, if you add a concentrated nitric acid to it, and if you add ammonium molybdate to it, NH4 twice MOO4, what you will have is ammonium 3 phosphate 12 molybdane O3. So you don't need actually you should just see this compound. You don't need to remember it much. Just remember that there are 12 MO3 in this compound, and it's the color of this compound is what? Canary yellow. So this in exam they will specifically tell you that the compound you yield is a canary yellow. So it's a characteristic color of phosphate test. So it will give you a inference that this could be due to phosphate ions presence. And the other reaction possibles are, I told you, is the redox type reaction. This is again forms an important part in the chemistry. And if you have a MnO4, it is usually of a pink and purple color. You must have used it in oxidizing agent and all. And if you do the reaction like oxidation and reduction in a acidic medium, it will go from plus to means if you check the oxidation state, if you know how to check the oxidation state, so this will be about +7 on manganese, correct? Because 2 4s are 8 and there's already negative charge, so 1 minus is +7 charge. Manganese +7 goes to manganese +2. So this turns a pink or purple compound solution to a colorless compound. And then if you have a chromium species Cr2O7-2, if you have this in acidic medium, this will reduce to Cr+3, right? So if you want like how reduction is happening, like similar in this, it is reduced, it goes from +7 to +2, so it is being reduced by 5 electrons. And if you see in Cr2O7, the oxidation state of chromium will be this will be so +6. You know how 7 2s are 14, correct? You already have 2 minus, that makes it 12, and if you divide 12 into chromium, it will be +6. So this is being reduced by 3 electrons. And the color changes. The Cr2O7 color is actually orange, and the Cr plus 3 ion color is green. And similarly, the Cr4 minus 2 color is yellow. Cr2O7 color is orange, and Cr4 color is yellowish, and they are actually visibly distinguishable if you look at them. And this again, if you do an acidic medium or redox reaction, this will give you a chromium plus 3 species, which is again a green species. And this is one of the important knowledge you should actually acquire, that Cr2O7 and Cr4 minus 2 actually remain in equilibrium. Sorry. And if you have a basic condition, Cr2O7 will dominate and the color is orange. And if it's an acidic medium, if you have a Cr2O7 minus 2, if you increase the pH, this will go to CrO4, and if you decrease the pH, that is making the solution acidic, right? Decreasing pH is making the solution more acid, more concentration of H plus in the solution. That means you'll yield a Cr2O7, and the color of the two species are different. So this completes the table of the acidic radicals, and then I will provide you some facts about these acidic radicals that will give you a confirmation test of which acidic radicals they are. So there's a lot left, even if already we've made one video over this, and there's a lot to cover. So please do follow this salt analysis series, because it's really important, and we'll give you any related links in the description box. And if you like this video, please hit a like button, do share, and do subscribe. Thank you. All the best.